There's a spirit that yearns to make the world a better place, a spirit of ingenuity. It's a spirit that has been handed down from generation to generation, and its push for innovation continues to grow right here in New Mexico, igniting our future. It's a spirit that causes us to dream big. Look around to see all the things we take for granted. Vehicles to drive, clean water to drink, safe food to eat, cities in which to live and work, and cell phones that connect us to limitless information and countless people across the globe. One profession is at the heart of each of these wonders of our modern-day way of life: the multifaceted field of engineering.
When you flush the toilet, when you wash your hands, when you cross a bridge, when you drive down a road, when it rains and your house doesn't flood, all that's due to engineers. So, to me, everything about the way that we live as a society is due to engineering.
Overall, our quality of life is much better than that of our ancestors, thanks to the innumerable clever and innovative strides that have been made by engineers. And while many point to the great engineering marvels from around the globe, you might be surprised with the notable engineering achievements here in New Mexico. Some great accomplishments were made hundreds, even thousands of years ago by the Native American peoples whose cultures dominated the land. The Pueblo Indians built villages, called pueblos, for security, for community, and for shelter from the elements. Residents of two pueblos in particular, Acoma Pueblo and Zuni Pueblo, regularly carried out trade and cultural exchange with one another. But they happened to be located 100 miles apart, a journey that entailed either crossing an 8-mile-long jagged lava flow or taking a detour to make the long trip even longer. The solution? The Pueblo Indians made rock cairns and simple bridges that made traversing the lava flow much easier. Interestingly, one of these pueblos, Acoma Pueblo, has been continuously inhabited for 800 years, a testament to the ingenuity of its builders. It was known as the Sky City because it was built on a large rock, a location readily defensible against attacks from other tribes. Another pueblo, Taos, is considered to be the oldest continuously inhabited community in the United States. It features a multi-story housing complex of reddish-brown adobe, an innovative structural work of art for its time. Partway between Gallup and Farmington stands another historic engineering success known as Chaco Canyon. The site flourished as a cultural hub for the Chacoan people for about 300 years, starting in the mid-800s. They built massive multi-story buildings out of stone using advanced masonry for that era. Very notably, the construction was planned out ahead of time, often to achieve alignment with astronomical markers and landscape features considered sacred to the culture. Visitors to the site, now a National Historical Park, can still witness the beauty and elegance of the building's engineered design and construction. A defining moment in New Mexico's history was the arrival of Spanish conquistadors and settlers in the 1500s. They immigrated north from present-day Mexico, crossed the Rio Grande, and made their way northward to San Juan Pueblo, now called Oquehuengue. To facilitate travel, they blazed what's become a renowned historical pathway, El Camino Real de Tierra Adentro, or the Royal Road to the Interior Land. The trail became a rudimentary highway, leading to the establishment of Spanish culture and religion in what's now the state of New Mexico. El Camino Real was used extensively for 280 years. Even nowadays, remnants of the trail can be seen on patches of undisturbed desert land, and many modern-day streets and highways follow the original route.
Hi, my name is Jose Pasillas. I'm pursuing my master's degree in geotechnical civil engineering. My family is a family of construction workers. When I used to go with my dad to the construction site, I remember the clients calling my dad ingeniero, which is the Spanish word for engineer. So I wanted to be an ingeniero. And later in life, I learned that it was the civil engineer, the person in charge of making the decisions in the construction site. So when I was about to finish high school, I knew I wanted to be a civil engineer.
Throughout the ages, mankind has had an ever-present need to transport cargo and people from one place to the next. Sometimes that need has been met with the construction of highways hundreds of miles in length, and, in at least one instance, it has been fulfilled with the construction of a mysterious staircase, allowing worshipers to move between floors of a small chapel. Loretto Chapel was built in the city of Santa Fe. However, a problem soon arose. Members of the choir had no way to access the choir loft, located 22 feet above ground level. As the story goes, sisters at the chapel prayed for 9 days for a solution to their dilemma, and on the 9th day, a toolbox-carrying carpenter appeared. He began work on what turned out to be an engineering marvel of its day, an elegant helix-shaped staircase that was built only with wooden pegs as fasteners, not with screws. The staircase appears to have no visible means of support, including a center column. Until recently, it was the only staircase of this type in the world. Once finished, the talented carpenter disappeared without a trace, adding to the seemingly miraculous nature of the story. Each year, tourists and engineers make their way to the chapel to view this wondrous structure.
We're faced with these challenges. There's something that has to get from A to B, and right now there's nothing there. And you're creating whatever is there, which means that there's a component of artistry to it as well. And I think the thing that's important to be an engineer is just the desire to want to do it.
Engineering has provided innovative ways for people to reach different elevations across the terrain. New Mexico boasts the nation's longest aerial tramway, Sandia Peak Tramway. Covering a distance of 2.7 miles, the cable car system carries passengers from the foothills of the mountains to the summit in just 15 minutes, an ascent of nearly 4,000 feet. The tramway, thanks to its engineered design, features just 2 support towers, the second of which measures 80 feet in height and had to be installed in place using a helicopter. The route is a shortcut for hikers, for skiers, and for tourists wanting to catch an overhead glimpse of the city of Albuquerque and the surrounding scenic landscape. The railroad reached Albuquerque in 1880. A year later, a new 2-story hotel had been constructed out of brick. The same year, a civil engineer platted the layout of the city of Albuquerque, which planned for its future streets and roads. The city's population now totals more than 500,000 people. The advent of the railroad brought professionally educated engineers into prominence. Mechanical engineers designed locomotives and cars. Civil engineers designed the roadbeds and bridges needed to maintain straight rail alignment. Rail transit and transportation continues to play a role in New Mexico. 2 major commercial rail lines traverse parts of the state. In 2014, Union Pacific opened a $400 million rail intermodal facility in Santa Teresa, along the state's international border with Mexico. In 2006, the first portion of the state's Rail Runner commuter train launched service. Subsequent phases have connected the communities of Los Lunas, Albuquerque, and Santa Fe, increasing transportation options for the state's population center. Once again, the many contributions of talented engineers made each project possible. The nation's interstate highway system transformed the nature of long-distance travel, and New Mexico's borders contain 3 such interstate highways: Interstate 10, Interstate 25, and Interstate 40. The latter 2 meet in Albuquerque at a junction known as the Big I. The engineered structure allows drivers to easily transition from one route to the other. Along with the Paseo del Norte at I-25 Interchange, 5 miles to the north, they accommodate not only cross-country travelers, but also a significant amount of local traffic. Other structures that have improved the driving experience for New Mexicans and others over the decades include the Rio Puerco Bridge, built in 1933 on U.S. Highway 66. It was the final obstacle to rerouting U.S. Highway 66 east-west through Albuquerque. The Nogales Canyon Bridge, which improved safety for I-25 drivers crossing a very steep canyon. And the Rio Grande Gorge Bridge, which spans a deep canyon and provides a vital shortcut between Taos and the east side of the Rio Grande and communities to the west of the river. New Mexicans know all too well how important water is to life. Much of the state consists of desert, and most residents are keenly aware of the importance of water supplies for drinking, sanitation, commerce, and agriculture. The engineering profession has helped to solve some of the state's major water challenges by creating infrastructure to account for, to store, and to channel this all-important, scarce resource. In 1888, the U.S. Geological Survey set up America's first stream gauging station, located on the Rio Grande near Embudo, New Mexico. It was established by noted American West explorer John Wesley Powell. Because of its success, this innovation spread across the entire United States.
Some people will say, wow, engineering, you must be smart, or you must really like math. And it's not even about that, it's about the way you think. Engineering is problem solving, and that you want to create things in this world that don't exist yet.
In 1916, the U.S. Bureau of Reclamation finished work on the massive Elephant Butte Dam. It was the largest irrigation dam in the nation and an engineering feat of its day. This was the first engineering project significant enough to result in an international treaty between the United States and Mexico. This 301-foot-high dam bottled up the Rio Grande near Truth or Consequences, allowing spring snowmelt runoff to be released each year in a controlled fashion for the benefit of irrigated agriculture. This helped to build the economies of downstream communities, including the city of Las Cruces. The dam still plays an instrumental role today. In the mid-1960s, planners in the city of Albuquerque recognized the need to accommodate future population growth and demand for potable water. A major engineering project launched in 1964 to capture water from the San Juan River in northern New Mexico and transport it through the Continental Divide to the Rio Grande, where it would bolster the irrigation and water supply. Absent a supply of river water, many communities across New Mexico have turned to underground aquifers as their main source of water. Chemical engineers have played important roles in ensuring this water does not contain dangerous levels of harmful chemicals, such as arsenic, and that it's safe to drink. Other engineering achievements have helped to tame the destructive force of water. Along with the construction of Elephant Butte Dam, a related project formed a defined channel for the path of the Rio Grande in southern New Mexico. This prevented the river from meandering wildly across the landscape and flooding communities. The Albuquerque Metropolitan Arroyo Flood Control Authority forms a broad network of drainage structures which channel water away from homes and businesses during storms. Humanity has a driving desire to explore unknown frontiers, both scientifically and in the physical world. Engineers have made significant contributions in helping to fulfill this demand for research and exploration. In the United States, there is a major push to use converted solar energy as a major source of the nation's electricity supply. One concept entails using solar energy to create high temperatures to drive steam turbines. At Sandia National Laboratories in Albuquerque, the National Solar Thermal Test Facility makes use of a 200-foot tower to test out this idea. Sunlight reflected onto the tower can result in temperatures of up to 600 degrees Celsius or 1,112 degrees Fahrenheit. Los Alamos National Laboratory in northern New Mexico features an 800 million electron volt accelerator. While nuclear engineers use the scientific capabilities of the accelerator, civil engineers supervise the design and construction of this unique facility. Many contributions by New Mexico engineers have impacted the field of aerospace exploration and travel. A rocket sled at Holloman Air Force Base near Alamogordo was built in the mid-20th century to test human tolerance to high acceleration. Colonel John P. Stapp was subjected to high G-forces to help define human limitations. The track, designed by engineers, initially measured 3,550 feet long, but has been extended to 50,000 feet today. Southwest of Socorro, New Mexico, the federal government built a massive radio astronomy facility known as the Very Large Array in the plains of San Agustin. 27 massive 25-meter telescopes were built on special rail cars so they can be easily moved for the purpose of exploring outer space via radio waves. The Y-shaped pattern of the rail tracks can result in telescopes being arranged more than 20 miles apart.
It's a lot of work, but at the end, if you're passionate about it, if you focus on what you want, that work becomes your strength.
Early rocketry experiments were carried out near Roswell by Dr. Robert E. Goddard, a true pioneer in his field. After World War II, German scientists were brought to White Sands Missile Range to apply their knowledge to the development of rocketry and spacecraft as the nation entered the space age. In 1982, the Space Shuttle Columbia landed at White Sands Missile Range at a runway carved onto the gypsum sand fields. The runway was a backup landing location for shuttles during the decades-long American shuttle program, and it also served as a training site for astronaut pilots. In recent years, the state of New Mexico has built a $219 million suborbital launch site called Spaceport America. It's the world's first purpose-built spaceport. This facility has hosted a number of rocket launches and will serve as a launch point for commercial spaceflight.
Great engineering happens every day here in New Mexico. To me, great engineering is engineering that helps people. And almost all engineering helps people.
While much has been achieved so far, there are big challenges on the horizon that will need the ingenuity and creative force of professional engineers. For those of you interested in dreaming big, consider the following projects that will need the mental energy of the best and brightest minds. There's a movement to develop driverless cars. Hand in hand with this, we'll need the roadways and traffic management systems to make sure the vehicles function well and safely. Improved runways and other facilities will be needed to support space travel, especially space travel that relies upon reusable vehicles. Better tracks will be needed to support high-speed trains for more efficient, faster travel. Another big idea on the engineering horizon in New Mexico is to build a pipeline from a major river on the eastern United States to import water supply. A critical need in New Mexico will be to develop more efficient water use practices and new technology and infrastructure to expand our water supply. Brackish water must be treated in an environmentally friendly way to the point of being drinkable. Cities are looking for ways to deal with wastewater treatment, including methods to remove contaminants such as nitrates, phosphates, and uranium for the safety of the public. There's a need to find innovative ways to treat gray water, which is recycled water. This will help to stretch our limited groundwater supplies. And research must take place to create new types of building materials that make structures both more functional and more economical.
Root-inspired foundations is a new approach to do geotechnical engineering. Here we're seeking to learn from nature how trees have evolved in order to sustain big wind loads.
In transportation, there's room for innovation in finding ways to speed construction of new projects, such as by prefabricating bridge components that can be installed in shorter periods of time. Strides can be made in the application of numerical models to design special structures. Nowadays, the staircase at Loretto Chapel could be designed by computer modeling. And let's not forget, there's a push for more efficient, renewable energy systems, including wind turbines and solar panel technology. Meeting these challenges is the spirit of ingenuity, which is alive and thriving in New Mexico. Many young students are already starting to dream big by exploring science, technology, engineering, and math.
Hi, my name is Berkan Dokmeci. I'm in 7th grade and I go to Desert Ridge Middle School.
Andrea has a bag of candy with 8 red, 12 blue, 4 yellow, and 16 green candies. Desert Ridge.
20?
Correct.
I like math because it's fun and the pieces, when you put them together, forms a nice puzzle.
New Mexico's past and present are packed with instances of people who showed the courage to dream big, and there are many more accomplishments yet to be made. Those achievements will be in the hands of tomorrow's talented engineers.
When I was growing up, I was in love with all the bridges that I saw around me, and I just wanted to help to create those. So now that I'm designing bridges so that they can be built here around the state, I felt like I was dreaming big when I was little, and that I continue to dream big.
Be ready to take on the challenges or opportunities that are going to be there whenever you're trying to achieve great things. Dream big as a civil engineer means to me that through my profession, I will be able to change the life of many people.
If you enjoy the satisfaction of helping people to live a better quality of life and applying scientific know-how to solve problems, consider joining this exciting profession and sharing a vision together for the future. Don't just dream. Dream big, New Mexico.